point P is -1, 1 and lies on the curve y equals 3 divided by x plus 4. In part A, you want to graph the curve. It's totally fine to use your graphing calculator. Please make sure you pause the video, sketch a graph, and then come back. So hopefully you saw that this curve has a vertical asymptote at -4. So x equals -4, we have a vertical asymptote. And then point P was that point -1, 1. And so your curve looks something like this. You have a branch over here, and then you also have another branch down here. In part B, we want to graph the tangent line to the curve at the point -1, 1, which is the point that we are calling point P. So here's point P. So again, imagine that you're driving along this curve, and when you stop at point P, your headlights are going to shine along this straight path, and that path would be your tangent line. So I'm having you graph your tangent line just so you can visualize what's happening in this problem, and also so that you have an idea of whether or not the slope of this line should be positive or negative. We're going to compute the slope in just a moment, and it's a good idea to know whether we're expecting a positive or a negative slope. So for part B, does this tangent line appear to have a positive or a negative slope? You can see that this line has a negative slope, so we are going to expect to get a negative answer in part C. Part C says, estimate the slope of the tangent line at point P by picking another point on the curve and calling that point, point Q. So let's say I move along the curve a little bit and I create a second point, which is point Q. And if I connect P to Q, this new line is a secant line. And we're going to be able to compute the slope of this secant line, which will be an estimate for the slope of the tangent line. So we want to estimate the slope by picking another point on the curve and then computing the slope of this new secant line, which we're going to call secant line PQ. So if the x value of point P is -1, then we want to pick an x value for point Q that is close to -1. So my picture here is not drawn to scale. I really don't want my point Q to be quite so far away from point P. I really want it to be a lot closer to point P, but it would just be hard to draw that to demonstrate what that secant line would look like if P and Q are really close together. But please understand, we want to get really close to x equals -1. So we might want to start by going from x equals -1 to x equals -0.9, for example. And we'll compute the slope from x equals -1 to x equals -0.9. Now I'm going to rename my function up here. Instead of just calling it y, I'm going to go ahead and just call it f of x so that I can write this in function notation. So the slope of the secant line PQ will be found by finding the y value, so f of -1, the y value at -1, minus the y value at -0.9, divided by -1 minus -0.9. Remember, you could also have it in the reversed order. That would be fine. And then you're going to use your calculator to go ahead and estimate that slope. So pause the video. Please make sure you're trying all of these computations on your own first. It looks like the slope from -1 to -0.9 is approximately -0.3226. So then we'll go ahead and compute the slope from -1, and this time we want to get a little bit closer to -1. So -0.99 will be a little closer to -1. And I really don't require that you write this computation out multiple times. So you don't have to write f of -1 minus f of -0.99 divided by -1 minus -0.99. I just need you to write it once so I can see how you got your values. And then once I have it written once, you can just go ahead and use your calculate to generate the rest of your slopes. This one should be about -0.3322. So I'm going to, again, allow you to pause the video and continue to compute additional slopes getting closer and closer to -1. And we're going to go ahead and put all of these slopes in a table. So I've created a table of values, and I've just kept track of my x intervals here on the left-hand side and the various slopes that I computed on the right-hand side. And you'll see that the very first two here of -0.3226 corresponded to the very first rate of change I computed from -1 to -0.9. And then my second one here, -0.3322, corresponded with my second rate of change here from -1 to -0.99. Then I also, in my table, not only did I choose values that were larger than -1, but down here you can see I also chose some values that were smaller than -1. And that way I'm approaching -1 from both sides. So taking a look at our slopes, we want to take a look at what these slopes appear to be approaching as my intervals, my x intervals, are getting smaller and getting closer to -1. And it looks like I have slopes that are approaching -0.3333. So they're approaching approximately -0.3333 according to my table. So for part C, if we're trying to estimate the slope of the tangent line, we could say from our table, it appears that the slope of our tangent line is approximately -0.3333. Or you could say -0.3 repeating. That would be fine as well. Now for part D, it asks you to express your work as a limit. Now I want to show you how you can generalize everything that we just did in part C and write it as a limit. So point P stayed the same. Point P was always the coordinate up here, remember. Point P was the point -1, 1. So -1, 1, that coordinate did not change. But for point Q, we were continuing to change the x value of point Q. And if we generalize and say we could pick any x value that we wanted, we chose several in our table, but we really could have picked any x value that we wanted. Then remember, to get the y value, you're always going to come back to this function, and whatever x value you choose, you're going to plug the x value in to get the appropriate y value. So you could say, whatever x value I put in, I'm going to get out f of x. You could write it like that. Or you could also write it, in this case, if I put in an x value, then I'm always going to plug into the formula 3 divided by x plus 4, and that's going to be my output. So that's kind of a general way of writing point Q. Point Q is always going to be some x value, and then whatever that x value is, you'll substitute into the function 3 over x plus 4 to get the y value. So when we write our point Q this way, we can actually come up with an equation for the slope of PQ. So if we go ahead and take y minus y, that would be 3 over x plus 4 minus the y value of point P, which is 1, all divided by the x value of point Q minus the x value of point P. So that really is going to look, and I'm sorry, I'm squeezing it in here, as looks like 3 divided by x plus 4 minus 1 all over x plus 1. So this is kind of a general formula that will get us the slope of the secant line PQ. So if we write this as a limit, we're really computing the limit as the x values are getting closer to -1. Remember, that was because -1 was the x value of point P, and we're computing the limit of this slope, which is 3 over x plus 4 minus 1 over the quantity x plus 1. And we've actually already computed this limit. We computed it over here by creating a table of values, and we got that the value of the limit is about -0.3 repeating. In part E, though, we can actually compute this limit algebraically using the different methods that we've learned so far. So remember, anytime you compute a limit, you're always going to start by trying direct substitution. In this case, we definitely cannot substitute in -1 down here because we would end up with division by 0. So that's not a possibility. So instead, we need to think of the numerator as really 1 over 1 and get a common denominator. So I'll need to multiply my second fraction by x plus 4 over x plus 4 to get a common denominator and combine my fractions. So this will be the limit as x approaches -1. My numerator will be 3 minus the quantity x plus 4. Don't forget those parentheses. Those are really important. Divided by my common denominator, which was x plus 4, and then that will all get divided by x plus 1. So if we distribute, we'll have the limit as x approaches -1. I'm going to distribute this negative. So I'll have 3 minus x minus 4 all over x plus 4, and then that is still divided by x plus 1. Notice I still have to write the limit each time because I haven't evaluated the limit yet. Then in my numerator, I have 3 minus 4, so I'll have -1. So that would be -1 minus x, all divided by x plus 4. So that's my numerator, and that's all divided by x plus 1. Now this is a complex fraction, so it's a fraction inside of another fraction. I'm going to think of this x plus 1 as x plus 1 over 1, and then I'm going to change my division, this big division bar, into multiplication by the reciprocal. So this is really going to turn into the limit as x approaches -1 of -1 minus x divided by x plus 4. And now I'm going to multiply by the reciprocal, which would be 1 over x plus 1. Now remember, the goal is to be able to do direct substitution. So I'm really hoping that I can find a way to get this x plus 1 to divide out. And hopefully you're starting to see that I'm really close. If I would just take this -1 minus x and factor out a negative, then I will be able to divide those quantities out. So by factoring in our next step, I'm going to factor out a -1, which will leave me with 1 plus x on top. X plus 4 is still on the bottom. And then at this point, 1 plus x is the same as x plus 1, so we can divide those out. That's going to just equal 1. So we are going to be left with the limit as x approaches -1. We have -1 times 1 on top, which is just -1, divided by x plus 4. And finally, we can do our direct substitution. So substituting in -1 for x, and sure enough, we will get -1 over 3, -1/3, which supports the work we did earlier in part C. We said we thought the slope was about -0.333, and indeed it's -1/3, which is equivalent to -0.3 repeating. Finally, we want to write the equation for the tangent line, and point slope is totally fine. We have our point here. We have our nice slope here. So we can just take this and go y minus 1, the y value of our point, equals our slope times x minus the x value of our point, which will simplify to y minus 1 equals -1/3 times x plus 1. And on an exam with me, point slope form is great. You can leave it like this. If you really want slope intercept, then you could distribute the -1/3, solve for y, and you could write this line in slope intercept form. I hope that helps.